A drug company was interested in the effect of sunlight on the amount of vitamin C in samples of a particular pill. 10 different pills were measured for their vitamin C content before and after being exposed to 30 days of direct sunlight. The company is interested in if the sunlight has reduced the amount of vitamin C in the pills. Perform the appropriate statistical test to make your decision at the 5% significance level. Show your work and write a sentence that puts your answer in the context of the problem. It says 10 different pills, but there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's really only 9 different pills. Okay, so we've got these 2 different samples, but they're not actually 2 separate independent samples, right? This is pill A before and after, pill B before and after. So this is not a 2-sample test. This one is a 1-sample test on the differences. So we're going to have to subtract these out, right? So 100 minus 90, that's 10. 102 minus 89, what's that? 13, etc. So we're going to have to subtract all these out, look at all of these differences, and we're going to have to compare these differences to 0. So the null hypothesis is that the mean difference is equal to 0, and that means that the sunlight had no effect, right? The alternative hypothesis is that the mean difference is different from 0, but now let's see, do they want us to do a 1-tailed test or a 2-tailed test? The company is interested in if the sunlight has reduced the amount of vitamin C in the pills. So that means the before amount should be bigger than the after amount. So the mean difference is bigger than 0. So this means that the sunlight was not effective, didn't do anything to the pills. This means the sunlight reduced the vitamin C's in the pills. Okay, so what I'm going to do is I'm going to go stat edit, and here's all my data, and then I'm just going to subtract the 2 lists, and now I've got my differences. Notice all of those differences are positive. So just at a glance, it does look like the vitamin C levels went down. So let's find our X bar. We'll go stat calc 1var stats on list 3 now. And I get an X bar of 10.33. My sample size was only 9, and my standard deviation was 1.87. So I'll do my t-score. And so that's going to be the observed value, 10.33. minus the expected value, which is 0, divided by the standard deviation, which is 1.87 divided by the square root of 9. And you can see that this is clearly going to be a very large t-score. So before we finish the calculations, don't forget we have to check our assumptions. Do we have independent, simple random sample with no outliers? And do we have the normality assumption? Okay, so it just says that there's a random sample, so we'll have to assume that this is less than 10% of all possible pills. That's pretty easy to assume. Simple random sample, we can assume that. No outliers. Well, we're not interested in these individual pills themselves. We're interested in the differences. So we're going to go stat, edit. We're going to look at this list here. It doesn't look like there's anything, doesn't look like there's any outliers there, but let's just do the box and whisker plot for list 3. And zoom 9. Okay, it's got this extra graph going on in here. Unfortunately, I forgot to turn that off, but clearly there's no outliers in there. And it's not that symmetric, but let's do the normal probability plot on it and see how asymmetrical it is. Zoom 9. Well, that's not terrible. So that's roughly linear, so therefore we can assume that the distribution is approximately normal. All right. And I had to check that, right, because my sample size was so small. So there's no outliers, and we have the normal probability plot is approximately linear. Groovy. So now we can go stat, test, t-test. Notice it's just a 1-sample t-test. We've got the statistics. Mean is 0. There's our average. There's our standard deviation. There's our sample size. We're checking to see whether it's positive, and we can calculate it out. So this turns out to be 16.5. So the probability that our t-score is as big as 16.57 is approximately, is approximately 0, right? Because it's going to be, what is that, 8.8 times 10 to the negative 8. Very small, 8.8 times 10 to the negative 8. So therefore, what do we conclude? We reject the null, and we conclude that the mean difference is positive. So it appears the sunlight had an effect. On the vitamin C.